Hello everyone. It feels great to be back at BSides Ahmedabad again. So today I'll be talking about some interesting findings from the past 1 year around like cloud-based supply chain attacks, and that have been fixed as of now. So please note that the vendors that are mentioned in this talk aren't the only ones affected, and So let's say you are a developer learning a new cloud service. You go to some official cloud documentation and it references a GitHub repository. You think that, hey, it's official documentation, nothing to worry about. You go through the steps, the scripts, and then you just follow whatever process that they have mentioned. And you don't think twice. Or maybe a friend sends you a website which is like an official Microsoft website talking about a tool which basically helps you download RAM or something, basically speeds up your system. And you're like, okay, it's Microsoft.com, there's nothing to really worry about, right? So there's a common thing between both the scenarios that I just described briefly. And we'll take a look at what are the shenanigans that can happen in the backend when these services are powered by cloud services. So my name is Nitesh. I'm from a beautiful state of Sikkim. I work at Trend Micro in the cloud threat research team. So my focus has been around cloud services since 2022. And I've been in the top 100 researchers for Microsoft twice now. And you can find my work on this single cute little web page. So in the next 35 to 40 minutes, I'll go through a brief background so that we can understand what we're talking about. And we'll go through some of the in-the-wild findings that I've divided into different scenes, and we'll wrap up with some takeaways. So the scenario that I mentioned right at the start of this talk about a legitimate subdomain of Microsoft.com or some official Azure documentation, right? Would you trust stuff that is present there? Probably yes, probably no, it depends. You have an implicit trust which is built from the reputation of that organization that you are working on. So implicit trust is something that we will kind of explore in the next 39 minutes maybe. So let's take a brief look at how software supply chain attacks have happened in the past. So Polyfill is a popular JavaScript library for browser compatibility. So its domain was actually compromised. I mean, someone else took over it, and around 100,000 plus websites were compromised because it was being mentioned in the JavaScript references, and there were no SRI checks as well. And this happened because of a dangling domain takeover, and even NPM packages were affected in this case. CCleaner back in 2018, this is a simple cleaner tool which helps you, optimize your systems. And it was backdoored, and it had around like 2.3 million PCs that were compromised. So it would actually it was actually compromised from a developer's workstation, and the credentials were stolen and then they were used. And when we're talking about supply chain attacks, we really cannot forget the stuff that happened with SolarWinds. So the Orion updates contained malicious code. It was also compromised, and it was able to propagate to like 18,000 plus customers with some really big names. And a lot of us already know about the code curve supply chain attacks, where there were some instances wherein attackers were able to basically exfiltrate the GitHub token, and then they were able to move laterally within the environment itself. It had typo squatting, obfuscation, NPM packages being affected, and whatnot. And when we are talking about supply chain attacks, open source is very much leveraged in a very different way as well. As we can see in this icon burst one, where it talks about gathering data from apps and websites. And definitely we cannot forget this awesome research done by Alex Birson, which talks about dependency confusion and how he was able to basically gain some initial foothold in a lot of organizations out there. And I'd like to mention this one more interesting bit about supply chain attacks. It can basically affect literally everything that you know that works on software. So be it Jenkins, be it any of those CI/CD tools, GitHub Actions, everything that you know can be used, can be abused as well. And retrospecting on how these supply chain attacks have happened, there's a simple pattern to it. You compromise that one single component on which systems are dependent. It can be because of weak passwords, unpatched systems, vulnerabilities, 0 days, domain takeovers, domain hijacking, CI-specific attacks, and a lot. So they can target any of your applications, and this is how it works, and it actually abuses implicit trust. So when it comes to cloud and how and if you think about cloud-powered supply chain attacks, how do they look like? Well, it may be raining everywhere, but that's a very bad joke. So I'll just move on to some background with a brief background of how these have happened in the past. And now we'll take a quick look at Azure storage accounts so that we can get a fair understanding of what is going to happen next. So Azure storage accounts, a quick 101, it's Microsoft's cloud storage solution. It's scalable, durable, available, secure as well. Different flavors for different use cases. You can access your stuff that you have stored in a storage account via REST API, SMB, NFS. It's similar to AWS S3 as well. So there are different types of storages. So blobs, files, queues, tables. These are the most popular types of storages that are used. This is just some basic introduction so that we can understand what we're going to talk about. So the usage, when we think of the usage of cloud storage services, it's very obvious. Like you can use it to share your web resources in these script image tags, sharing files, backups, hosting static sites, and a lot more actually. So these blob stores can be accessed via REST or HTTPS as well. So in this example, the name of the storage account is Sally, followed by a container that is named pictures, which is like the directory or the folder that you can think of, which is followed by the blob, which contains the image, which is image 001. Similarly, there's a file type storage as well, where again the account name is Sally, and the file share name is pictures, followed by the folder or the blob, which is image001.jpg. So there are various ways to access or delegate access to a storage account. One is via a shared key, which are basically two 512-bit keys. There are two because there's a primary and a secondary one. So if you want to change one, then you can use the other, and it gives access to the storage account objects and the configuration as well. And then you have shared access signatures, which are basically URLs that are signed using the shared key, and it's used to delegate access to resources in a storage account. And you have enter ID, and obviously the worst one, that is the anonymous access. So particularly for today's session, we'll focus on shared access signatures. So there's this tool called Azure Storage Explorer. It's from Microsoft. It's an official tool. And you can use these keys or these SAS tokens to basically browse or work with the Azure storage account that you have found. Or if you're brave enough, you can use curl or the REST API like bare hands. So here's an example of a shared access signature. So everything that you see in yellow is the shared access token. And so there are specific URL parameters like SV, SS, SRT, SP, and all these things, right? So these URL parameters are actually well defined and documented as well. So we'll particularly focus on these 4 URL parameters: SS, SRT, SP, and SE. So basically, SS is implying that the SAS token applies to blob, file, queue, and table services. The SRT variable, in this case, it applies to service level, container level, and object level operations. SP is basically the permissions of this SAS token, which enables it to read, write, delete, list, add, create, and all these other roles. And then you have the expiry of this SAS token, which is set to sometime in 2051, which is way farther. So now coming back to the example, we'll just describe how this entire string looks like. So we have the storage account name, followed by the service host, followed by the public data sets is the container name, and the tar.gz file is the blob name, followed by the accessible services, the APIs that are accessible, so service, container, and object level APIs, the SAS permissions, the expiry of this SAS token, and yeah. So SaaS tokens are of three types. Account SaaS tokens, which can allow for access to multiple storage services, so it can be blob, file, queue, and table. The maximum validity that you can set is to 9999 years, and it's secured with a shared key. It's similar to service SaaS token, but the service SaaS token is specific to one single service. And yeah. So particularly we'll focus on the account and service SaaS tokens for this session, as they are easy to misconfigure, and you can set the maximum validity to 9999 years. Cool. So there's this one thing about SaaS tokens, that it is created from the shared key or the user delegation key. What this also means is that the SaaS token generation is not an Azure activity. What this means is there are no logs generated if you create a SaaS token from a storage account credential. And there are no logs, so you cannot track. And if you want to invalidate any SaaS token that you have leaked out, you have to rotate the storage account key itself. So we have some sort of background on what we are going to take a look at. We took a look at the storage accounts, we took a look at different services, some ways of authentication, authorization, and now we'll do some reflections on the basics. So it's very interesting to note that these SaaS tokens are basically just a bunch of URL parameters, and so many bug bounty hunters are there, researchers are there, right? So URLs are often logged everywhere, like a lot of places, like server side, any referrer headers, browsers, and if there are any inline proxies, yeah. And there is a CWE as well, so it's very much well known. It's not like something that we don't know. And this was also observed in my session last year, that we had actually observed the users JWT being logged in Nginx access logs on Azure ML compute instances. And this is a well-known thing on Jupyter server. So you can specify your token as a header or as a URL parameter or in the password field itself. So now we start with the beginning, but we need to take a look at some of the history. So SaaS tokens, this is one of the blogs that I found that have that talk about how SaaS tokens can be abused. So it's from Sunil Yadav, Not So Secure. And there was this recent news as well. I mean, it's not very recent, but it's kind of recent given my age. It's September 2023, where a SaaS token was actually used by researchers at Wiz to access 38 terabytes of data that was accidentally exposed in a storage account. And so the storage account contained a lot of other things as well, like employee backups of some former Microsoft employees, the machine learning models, the data sets and all. And then Microsoft actually released their end of the story, like, hey, we had actually found that, but it was marked as a false positive. But now the system is fixed. They have GitHub secret scanning in place, and they are already reporting on the overly permissive SaaS tokens. And that's the end of the story. So if there are any questions, we can take that now. Thank you. Okay, I think that was not a good one. So we are just starting now. So we'll take a look at Microsoft documentation first. So how do you learn something other than YouTube or those 1-minute engineering videos? Through documentation. So Microsoft documentation is there on GitHub. It contains the how-to of Azure services, and it's also open to user contributions as well. So during some searches that I was performing for exposed SaaS tokens, I came across this one documentation reference which talks about Azure SQL managed instance, which is like a scalable cloud database service. So you can, create your DBs and all on a managed instance, which is on Azure, and you can work on that. And here's a tutorial to basically restore a sample database. And these documentation instances, they are actually mapped to GitHub repositories. So if you notice in the GitHub repository, they have an SQL statement which says it creates a credential with a specific identity where they have specified a secret as well. So the secret actually contains an overly permissive SaaS token. If you notice, the secret is the SaaS token, and it has the services set to blob, file, queue, and table. The APIs that are accessible for service, container, and object level APIs. The permissions are read, write, delete, list, update, and all these other permissions. And the expiry of this SAS token is 2028. So this means that this SAS token is valid. I can use it to possibly mount or maybe access the storage account and also write on the storage account. And this is an account SAS token. So using the Azure Storage Explorer, we were able to access the storage account, and if you notice there is a file called nswas here, so that was me. I was able to upload files on these storage accounts with write permissions. And implicit trust was kind of broken. So as I'm able to upload a file or manipulate a file on that official storage account that is used in Microsoft tutorials and is also mentioned on their subdomain, I was curious to see whether if I could perform some sort of code execution if there are any instances out there. So the way for that was to use stored procedures. So in this case, I create a stored procedure which basically enables XPCMD shell, and then I'm able to execute command if you are running any of the procedures that are in this database. So as you can see, I'm able to run whoami, and I can view the POC file as well. So the impact here was that we could achieve code execution via backdoor stored procedures. This was reported to MSRC, and they had already, they fixed it basically. So this was one. The other is Kernel CI. So Kernel CI is basically an automation or a test system for testing upstream Linux kernel systems. And it helps basically ensuring the quality and the stability and the long-term maintenance as well. So Kernel CI also standardizes the hardware testing for the Linux kernel across all the possible widely used hardwares. And they have certain dashboards and a GitHub repository as well. So what we found was that it provides some sort of early access to users for testing the Linux kernels. And the way it does is it gives them access to a file share that is owned by them. And the file share contains, to access the file share, you need a SAS token. And the SAS token looked something like this. So it had again, the read-write permissions. It was expiring at a much later date. And these SAS tokens could be then used to basically access the storage account again, and I could again write files. And this actually means that I could have possibly modified other users' test kernel builds, achieved potential code execution on kernel CI's test build system, alter testing results for other users, obviously, because we can write to any of the files there, and potentially abuse this storage account for unauthorized storage as well. So the fix here was that they removed the SAS token that was mentioned in their GitHub repository. They probably also rotated the storage account key so that the token was invalidated. And yeah, so this was about kernel CI. Then when you think of these URL parameters, one of the most common things is to maybe just go haywire and scan the internet. And let's see what we found on the internet out there. So storage accounts talk about scalability and durability as well, and availability as well. So let's say there is a storage account where you have mentioned or where you have kept your JavaScript files, images, other web resources that you have referenced elsewhere, like in your Android apps, websites, Mac OS apps, and all those. So these resources are all stored in one storage account, and they have been referenced in other places. So we did a quick scan of domains containing references to SAS tokens, and here we see a mention of a JavaScript file that is being referenced using an account SAS token. And the SAS token has read-write permissions. And we found the same SAS token on 7 more websites, so total 8 websites. And if you see where this is going, basically the SAS token is over-permissive, and I can I can basically override this JavaScript file. And there were no SRI checks, so sub-resource integrity checks were missing as well. So the impact was that I could maliciously modify the JavaScript file that I found from one of those websites, which was referenced in 7 other websites, and I could have possibly compromised the entire other websites as well. So total 8 websites with read-write SAS tokens. The JavaScript file could be modified. And the endless possibilities, obviously, like credentials harvesting, browser-based crypto mining as well. So do you know browser-based crypto mining? I did not know that. So there's this cool talk which talks about hijacking a JavaScript library that was being used in a bunch of government websites, and they were being abused to mine cryptocurrency on users' end. That is pretty cool. Yeah. So now we move on to Microsoft PC Manager. So Microsoft PC Manager is a tool that we as kids, maybe 10, 12 years ago, would like to have. It would help us basically download RAM from the internet, like basically make our systems a little more speedened up. So you can speed up your Windows devices, you can clean your applications, clean storage, optimize your startup, file utilities. It's similar to CCleaner in a lot of ways. So to install PC Manager, there's this tool called Winget. Winget is basically a package manager for Windows 10 or Windows 11, and it has a CLI as well. So you can define these package information as manifests. So these manifests are basically YAML files, and you can source them from 2 different sources. So from Microsoft Store, which is apps.microsoft.com, or Winget, which also has a community authored GitHub repository as well, which is mentioned in this GitHub repository. So this is how the YAML file looks like for a Winget package. And if you notice, there is this thing called installer URL and installer SHA-256, which basically contains the path to download the installation file, which can be an MSI installer, .exe, nullsoft installer and all. And the installer SHA, which is basically calculated by the Winget CLI from the installer that we are working on. So okay, cool, yeah. So in one of these manifests, what was found that there was a SAS token which had like read-write permissions, and this was kind of interesting because it is mentioned on Microsoft's PC Manager YAML file itself. And if you want to install any package, this is how you can install it, like Winget install. You specify the ID of that tool that you want to get on, and this is how it works. So if you notice the URL, the SAS tokens is like read, write, delete, and list permissions. So let's see what we can do with this. But first, the domain looks a little different. It looks like pcmanager.officeplus.cn, a Chinese domain. So I was just playing around with this domain, and I was just trying to see what are the other things that I can get out of it. And I found that we could get the underlying domain to which, the storage account to which this domain was mapped to. It's not really a sensitive information disclosure, but it helps me connect easily and directly now. So it turns out that we could browse the container named, like the directory named MVP in this storage account using Azure Storage Explorer. And we had write permissions as well. There were around 20 gigs of internal debug builds as well. So the impact here was that we had read, write, delete, list permissions on around 358 GB of Microsoft PC Manager that was being distributed via Winget, which contained like 20 gigs of internal builds. So we could infect end users of Microsoft PC Manager via Winget and apps.microsoft.com as well. And this is a POC that I crafted. So basically I was able to upload a file on that storage account, and who does not love a POC, come on. And the impact here is that auto update is enabled by default in Microsoft PC Manager. So if I replace a file on that storage account, and if there is no, because there is this implicit trust again that is in play. And if I replace a file on the storage account, that gets updated on all the endpoints, you know where this is going. And you could potentially carry out a supply chain attack by replacing the MSI installer and propagate across Microsoft end users as well. But the interesting bit was that Winget has its own defenses, like the installer SHA-256. So I was not able to bypass this. So the mismatch in the CLI itself does not lead to a direct code execution. So if I replace a file on the manifest and I expect a code execution, that's not going to happen. And there are certain flags to disable integrity checks, but they need admin privileges. So not really my thing right now. So this is how you can basically enable the hash override, and then you can basically install the Winget package that you want to install without validating the SHA-256, which is not cool enough. Which brings me to Microsoft PC Manager Scene 2, which is the director's cut, and now this is the coolest part of the presentation. So if you know you can do better, then do better. It sounds very simple, right? And compromise via Winget is fine. I mean, I don't even use Winget. So how popular is PC Manager? Like, how popular is this tool, and where else can we get this tool from? Is there a dedicated official website? So I did some searches on Google, and it seems like it's kind of popular. Like there were a couple of blogs from PC World, Bleeping Computer. They all mentioned that, hey, you can use this PC Manager to speeden up your system and all that. This is just to show that this app had a lot of existence there. And it had this particular subdomain mentioned, which had pcmanager.microsoft.com. Okay, cool. And it was also mentioned in the apps.microsoft page for this tool on the publisher info itself. So this is how the website used to look back then when I was working on it. And you see this cute little download button there. So when I click on download, I get redirected to this AKMS URL. So AKMS is a URL shortener from Microsoft, and they own it, right? So this is again a trusted URL itself. And this basically sent me to another domain, which is a storage account followed by a SAS token. And folks, if you can zoom in a little bit, you can see the read-write SAS token, which was a service SAS token. Okay, that should be fine. And you can see that the expiry of this token is somewhere around 6th of March, 2024. So AKMS URLs were also found on various other places on support forums left and right. So you can see these AKMS URLs. So all of these URLs were actually using a SAS token that had the read-write permissions. And as you can see, I was able to again get access to the storage account. I was able to upload a file, and this was here. And it had around 118 gigs of releases that could be compromised via AKMS URLs and pcmanager.microsoft.com. So the impact was, again, read, write, delete list on 118 gigs. We could infect end users of PC Manager through this official subdomain. And this is how I crafted a POC for this. And here's a quick video. So I go on Google and I search for PC Manager. So I hit on the first link. It's not a Google Ads, don't worry. Then I am headed to this page. I click on Inspect Element because why not? Then I go to the Network tab and I click on Download. And I just save the file. I copy this link's URL. And I head back to Storage Explorer. I connect to the storage account using the Azure Storage Explorer itself. I click, yeah. Okay, so I'll just reiterate that I have access to this .exe file, where the expiry is sometime in 6th of March. I have read, write, delete list permissions, and I click next, and I hit connect. So once I'm connected, it will be mounted as a blob container. So the container name is MVP1. And I go a level up, and if I can see, I have other files as well that can be replaced. And now I show you the SAS token that I have used. This is the same SAS token. I have already uploaded a file on this storage account. This is just for the video. I'll just scroll down to the bottom, click next. And you see this NSOCR file. So this was the file that I was able to upload. This is just to show that I could replace any of the binaries as well. It takes a while to open. All right. So these two issues were reported via the zero-day initiative. They both were assigned a CVSS of 10 last year. So the impact here was that I could basically replace the PC Manager tool that was mentioned on their official subdomain and Winget as well. So these were a couple of fixed commits that were seen. And it was first committed on GitHub on 5th of November 2022. With the SAS token, which was reported on 28th September 2023. So the initial fix for this was they just changed the permissions, created a new SAS token with just read permissions, and this is totally fine. There's no issue with that. And the attacker basically, in this case, uses the SAS token to get into the storage account which contains the PC Manager builds, the releases, that are mentioned across apps.microsoft.com, pcmanager.microsoft.com, AKMS URLs, and the Winget manifests as well. So when we think of the takeaways and when we think of the hope that brings, that is brought along, we need to figure out who is able to use these SAS tokens to access a storage account. So one of the initial ways to figure out could be by enabling logging, and then you can take a look into the user agents. But you can start off from the user agents. You don't need to just stop there. When we think of any overly permissive SAS tokens being used, so there are ways to detect that, but you cannot find which particular SAS token is being used. So the signature field is missing. So you can leverage Azure storage analytics logs, but with caution, because if your storage account is heavily used, you will incur a lot of cost. You can check if an overly permissive SAS token is being used, and you can also check whether a SAS token is being used. So when we think of hunting for SAS URLs, there's this very simple GitHub code search query that I started off with, where I'm looking for the content which contains SP equal to RW, like any of these two, and the expiry sometime later. And obviously you can add more filters like not is fork, or you can scope it to a specific organization or a GitHub repository. And you can expand based on experience. Like there are so many tools out there, so many cool project discovery tooling as well, so you can leverage all of that. So the takeaways, start with the bare minimum privileges and work your way upwards. So this is for any of the tokens, any of the credentials, any of the permissions that you assign. So if you are having to use these SAS tokens or like such sort of mechanisms like AWS pre-signed URLs as well, you can basically use short-lived SAS tokens, or if you want to create a SAS token which is like valid for a longer period of time, you can use stored access policies. And you can obviously like inspect your network traffic for read-write SAS tokens, and you can also scan your code for these SAS tokens. So it does not only apply to SAS tokens, but any other cloud credential that you see elsewhere. And probably it's time to also update your Trufflehog or Git leaks, and most importantly grep. And from the code perspective, code bases, IAC files, Docker Compose, Kubernetes YAMLs, and all of these other things. And this is one image that I had to put because all modern cloud infrastructure is all dependent on one single overly permissive cloud service credentials. Audit, assess, don't assume trust. I don't like to use the word zero trust really, but I think this is a case where you have to focus on that aspect as well. You need to develop some sort of detection response mechanisms for anything that you're exposing publicly. You need to vet everything that you're using and working, integrity checks and all, malware checks and all. And whatever you can log and work on, please do it, because there's no other way to figure things out. And obviously, please keep the cost in mind. And there's more. So it's not just Microsoft. There are other vendors as well that were affected that we found in our research. We leveraged a lot of open source tools as well. We found a lot of credentials on threat intel platforms like VirusTotal as well. So it's all in the process. A lot of them have not been fixed yet. So coming back to this image that I had shown earlier, it all starts with code. It just ventures its way to cloud. If your code has vulnerabilities, if it has malware, if it has backdoors, it will just propagate to cloud, and you need to fix things right at the start. I'm not saying something new, but it's something that kind of resonates with what we are finding in the wild. And now when we come back to implicit trust on official Microsoft subdomains, it's not just Microsoft. I'm just repeating that again. And official documentation, implicit trust is kind of broken. So that was my session. I'm open for any questions, for any hard questions that you may have. And okay, let's wait. Yeah, we have two questions, okay.
Okay, can you hear me now? As you know, on the Windows, there is a universal access control for download files. So when you... Are you able to understand, or should I talk slowly?
You need to be a little louder, I guess.
Okay. On Windows, you know, there is a universal access control for the downloaded files. And you said you were able to upload any file or change contents of the already uploaded files on the PC Manager's Windows blob. But were you able to bypass this? Because if you don't have any valid signature on the file, Windows, it will just block the file and warn the user. And from what you showed on the slides, I see you needed to change the permissions on the winget itself. So I am wondering, how were you able to bypass, if you were able to bypass? If you're not, how Windows treated this as a accepting report, or like in medium severity, high severity, or critical severity? Because in these terms, you are basically forcing user to enter comments, which is not different than entering comment on the user's computer itself. So I'm wondering if you are able to bypass the signature. Because it is not, it is just basic file upload. So I'm wondering how Windows, Microsoft itself treated this as a severity, how they validated itself.
Yeah, that's a great question. So the question is on bypassing the signatures of the files if I had the permissions to upload or replace a file on the storage account. So for the winget case, we had the installer SHA-256 that was mentioned in the YAML itself. So we cannot bypass that.
Understand that one. I'm not asking for that one. You were showing the URLs. You said on winget, you were not able to do it because of the signature on the SHA-256. But on the next slide, on the scene 2, you showed that there's some aka.ms URL, which is forcing user to download file. What I am asking, let's forget the winget. On the downloaded file itself, were you able to force user to bypass universal access control? Because if it is not signed by the Microsoft itself, Windows will prevent user and saying it is from unknown source. And how Windows treated this? This is what I am wondering.
So you're asking about UAC bypass?
Yes, because this is not different than uploading files on the Amazon's S3 buckets. As long as you know you are not able to do anything, that is not actually impactful for myself. I'm an experienced user. But for normal user, you are just forcing them. So the thing I'm wondering, how Windows, Microsoft itself classified the severity of the issue and treated this. Because in, let's say, in bug bounty perspective, or in pen testing perspective, I would classify this as low impact. Don't get me wrong. I understand you were able to upload files on the blob, which is not different than any bucket on the AWS or Azure or let's say GCP. But the thing I'm wondering, how Microsoft classified this?
So I think that's a comment that Microsoft can add to it, right? That's the first one. And the other thing that you're talking about, validating or bypassing the signature itself. So the case here is that I'm not forcing a user to even click on a link. The thing is, if we talk about the auto update scenario.
Yeah, the thing I'm asking for the like 5 slides ago, I think, from this one, the aka.ms, you show that
yes.
aka.ms/PC manager 500,000.
Yes.
I'm wondering for this stuff, how it could be malicious for the user, because you are not able to bypass the universal access control.
Yes. So, okay, now I understand your question. It took me some time. So these AKMS URLs, so these are all, AKMS is basically a Microsoft owned URL shortener.
Yeah, I know.
So implicitly you will be trusting it. Even if there is any sort of file that is not signed, right, you will be trusting it because based on the fact that it's an AKMS URL.
No, it won't. No.
I mean,
universal access control just doesn't trust the domain. You are getting it wrong. It will check the signature because it will say unknown source.
Yes, but the thing is,
that is what I am wondering. I understand your point. That is good vulnerability. I'm not saying it's bad. The thing I'm wondering, how Microsoft handled this. Because for Microsoft itself, this should be low impact. Because you are not able to do anything to user's computer. Because you are not able to bypass the universal access control. Because this file is not signed by the Microsoft or let's say Windows itself. So you will share, just let them download the file from the blob of the windows.net, but it will be showed as an unknown source when they try to run.
So I think that depends on the user's awareness as well. So if they're downloading a file from an AKMS URL.
Yeah.
Right.
I mean, I understand. If we care for the user's awareness, then everything should be critical for us. The thing I am wondering, not your one, I am wondering how Microsoft classified this.
So the process was like we reported it to Microsoft, we showcased the POC as well.
Yeah.
And they fixed it by replacing the SAS token with a read-only SAS token. So that was the fix. And
okay.
Yeah.
No. The thing I am wondering, is Microsoft treated this as low impact, medium impact, high impact, or critical impact? Because if I was a Microsoft engineer who was going to triage this, I would classify this as low impact.
Okay. I think I can't comment on that as of now because we haven't seen any public statement from Microsoft on this.
No,
we have just seen the
you could
fixes.
just say they just paid the highest bounty. That's the information.
Oh, okay. On the bounties, so ZDI does not take any bounties from its vendors that it reports to.
No, I mean the bounty, let's forget bounty. Let's say they say this is a very high critical issue for us. That is what I am wondering.
I think I can take that offline or any other folks that can join in as well.
Okay, no problem.
Because I'm running out of time here.
Okay.
There was one more question I think at the back there. We'll just. Okay, I'll take the other questions offline. I'm having some time cut here. So that was all, folks, from my side for these SAS token abuses. And really thank you for your time. And let's connect. So I'll be around as well. So thank you.